Guys, I hope everybody's doing well. The purpose of this video is to just kind of refresh your memories and do a recap on what we've covered so far in functions. So, just to start from the beginning, okay? Here we want to take these and we want to kind of fill the ordered pairs into a table, a mapping diagram, and then plot them as well. So this would be the X, this would be the Y, 3, 4, 5, 1, 0, 2, 1, 4, and 2, 2. If we were to do a similar thing here with the mapping diagram, we would put in 3, 5, 0, 1, 2, 4, 1, 2. Now, I don't need to repeat the 4 and 2 because I already have them. So 3 goes, hold on. All right, sorry about that. So 3 goes to 4. Oh my gosh. 5 goes to 1, 0 goes to 2. 1 also goes to 4, and 2 also goes to 2. A little sloppy. I don't really prefer those, but now, if we were to plot them, where I basically make this my origin, this my x-axis, sorry, this my y-axis. So 3, 4 would go here, 5, 1, 0, right? And then up 2, so 0, 2, 1, 4, and 2, 2. Fine? So that's just a little intro to that. So a function is a relation. This is a relation up here. Okay. So a function is a relation in which each input is paired with exactly one output. So basically your x's, x values don't repeat. Okay. So when you look at this, none of the x's repeat, so this would be a function. Here, these x values repeat, so not a function. Here, none of the x's repeat, so this would be a function. It doesn't matter if the y's repeat. So would this be a function? So if you think about it, let's write this as ordered pairs. This would be 2, 6, 3, 7, 4, 7, and 5, 9. So do the x's repeat? Nope. So this would be a function. How about this guy? Well, when you have a visual, you can do the vertical line test, which I elaborate on a little bit below. But if it helps you to write the ordered pairs, so this would be 2, 3, 2, 5, 4, 4, 5, 2, and 6, 6. So here the x's repeat, so this is not a function. So we could have used the vertical line test above. Basically, if you can draw a vertical line and it hits your graph more than once, then it's not a function. So for example, I can never draw a vertical line and it ever hits my graph more than once. This would be a function. And with this, nowhere will I hit it more than twice if I draw a vertical. This would be a function. However, this, I drew that vertical line and I hit it twice, so not a function. But then we had started into evaluating functions. So this is function notation. Okay, so if I say let's evaluate f of 10, f is just telling you which of these functions above you want to pick, so the f one, and 10 is telling you the x value. So we're going to put 10 in for this x. So we're going to say 4 times 10 plus 2, and then from there you just evaluate this. So 4 times 10 is 40, and then plus 2 is 42, and that's your answer. So this is simply telling you what value to put in for x. So if I said let's do g of 2, so here's my g function. I'm putting 2 in for my x. And then from there, let's do this math. 9 times 2, order of operations, do the multiplication first. 18 minus 5 is 13. Now, from here, we elaborated a little bit and we brought in functions where you add to or subtract to or multiply. And this will be new. Number 5 will be new. Okay, so I'm going to go through a couple of these. So f of negative 4. If you want to try this on your own, pause the video, try it on your own, and see if you get the same value. Okay. You should get 14 there. Put negative 4 in for x in the f function. G of negative 10. Once again, if you want to try it on your own, I would encourage that. You should get 3. You can pause this video at any time to try stuff on your own. Okay, now, this we had just started into the last day I was with you. You should do g of 12 first, then do f of 12, and then whatever you get from each of those, we'll subtract them. So let's start with g of 12. So we're putting 12 in for x. 1/2 times 12, and you can totally use a calculator for this, is 6, and then plus 8 is 14. Let's do f of 12. So we're putting 12 in for the x in the f function listed here. -2 times 12 is -24, plus 6 is -18. Now, take the g, okay, which is 14. We're going to subtract the f, which was -18. Well, minus a negative turns to plus. Once again, you can use a calculator. In our Zoom meeting, I will go through a calculator that you can download to use. So if we do that addition, we should get 32. Okay, I'm going to skip over this guy for a second and go to this one because it's similar to that one. So let's find f of 6, then we'll find g of 6, and then we're going to add those two together. So we're going to put in 6 to the f function. So this is -12 plus 6, which would be -6. And let's do the g function. So we're going to put in 6 to the g function. So 1/2 times 6 is 3, plus 8 is 11. So now take the first part plus the second part, and you should get 5. All right, let's go back to this one. So if there's ever a number out front like this, we're just going to multiply, well, actually, let me erase that, sorry. We're just going to multiply whatever we get from this part by 4. So let's do f of 3 first. So let's put 3 in for our x. -2 times 3 is -6, plus 6 is 0. Now, I know anything times 0 is 0, but we'll take 4 times that answer, and you should get 0. Okay, so if there's ever a number out front like that, do this part first. Whatever you get from that, multiply by 4. All right, the last part here, this is kind of new. Notice there's no number there for the x. So we're simply going to take f of x as it is, plus g of x as it is. Okay, so we want to just combine like terms from here. So -x plus -2x plus 1/2 x. You can use the calculator for this. That would be -1.5x, or if you wanted to write it as a fraction, -3/2 x. Totally up to you. 6 plus 8 would be 14. So you can write it like this as well. It's totally up to you. So you're really not doing anything but combining like terms between the two functions, and that's it. Okay, from here, I'm going to have a practice worksheet and some Delta Math practice for you to complete.